dear student. In today's session we will be doing nodal equations by inspection method. We have already studied how to do nodal analysis, but here we will be doing by the inspection method. So let's start. Draw the diagram. Now in this is the main diagram. Once you have finished drawing the diagram, let's analyze. We have voltage VA, voltage VB, and this node, that is node C, is given as your reference node. So it is at zero potential. Similarly, with respect to node B, I have drawn the figure B, and this is your figure A. Now if you see figure A, all the currents are leaving the node. At figure B, what is happening? I3 is entering the node, whereas I4 and I5 is leaving the node. So we can actually write down the equations. Let's start with the equations. Sum of currents is equal to 0 from figure A. So it will be I1 according to the KCL. So I1 plus I2 plus I3 is equal to 0. So if you consider I1, what will it be? VA minus V1. This is V1. Sorry. So VA minus V1 upon R1 plus I2 will be VA upon R2. IT will be VA minus VB upon R3 is equal to 0. Now if we apply KCL to figure B, we get I4 plus I5 minus I3 is equals to 0. In other words, I4 plus I5 is equal to I3. As I3 is entering node B, it gets split into I4 and I5. Therefore, I3 is equal to I4 plus I5. So if we can directly say that I4 plus I5 is equals to I3, because I3 is entering the node and I4 and I5 are leaving the node. If you see over here, VB minus VA upon R3 is equal to I3, VB upon R4 is equals to I4, VB minus V2 upon R5 is equal to I5. So if we continue with it, if we rearrange the terms, we will get 1 upon R1 plus 1 upon R2 plus 1 upon R3 VA minus 1 upon R3 to VB is equals to 1 upon R1 V1. So finally we get the equation as minus 1 upon R3 into VA plus 1 upon R3 plus 1 upon R4 plus 1 upon R5 into VB is equals to V2 upon R5. So in general, the above equations can be written as GAAVA plus GABVB is equals to I1, GBAVA plus GBBVB is equals to I2. That is nothing but G into V is equals to I. These are general form of equations. Now where GAA is concerned, GAA is nothing but 1 upon R1 plus 1 upon R2 plus 1 upon R3. That is the sum of all the conductances connected to node A. Where GBB is concerned, it is 1 upon R3 plus 1 upon R4 plus 1 upon R5, and GAB, that is your mutual conductance, is given as minus 1 by R3. Mutual conductances all will have negative signs. Similarly, when I say GBA, it is also a mutual conductance, so it will be minus 1 by R3. I1 and I2 will be your source currents. At node B and A, node A and B will be at node A and B. The current which enters into the node will have a positive sign. The current which leaves the node will have a negative sign. Let's go to the next problem. I hope you all have understood how to perform inspection method. Let's go to the next problem. Question for the circuit shown. Write the node equations. By inspection method. Draw the circuit diagram. Remember, conductance is inverse of resistance. So let's start. The general equations are given as GAA VA plus GAB VB is equals to I1. GBA VA plus GBB VB is equal to I2. Now let's find out what is the value of GAA. GAA is the self-conductance at node A. So what will be a self-conductance at node A? This resistance will come into the picture, this resistance and this resistance. So it will be inverse of all resistance, 1 upon 1 plus 1 upon 2 plus 1 upon 3 more. The unit for self-conductance is mho. Similarly, what will be GBB? That will be the self-conductance at node B. Sum of all the self-conductance at node B. So over here, which are the resistors that are coming into the picture? It will be 4 and 2, both are in series. So it will be 6 ohms, 5 ohms and 3 ohms. So it will be 1 upon 6 plus 1 upon 5 plus 1 upon 3 more. Let's find out this mutual conductance. Mutual conductance GAB. Mutual conductance GAB, that is the mutual conductance between nodes A and B. What is the mutual conductance between nodes A and B? That is 3 ohms. So it will be minus 1 by 3 mho. And similarly, we have to find out GBA, that is again the sum of mutual conductances between nodes B and A, so it will be minus 1 by 3 mho. So let's find out the currents. Current I1 will be, what will be the current I1? That will be your voltage upon resistance. So it will be 10 upon 1, that is 10 amperes. That is the source at node A. Similarly, I2, what will be I2? I2 will be 2 upon 5 plus 5 upon 6. How you get 5 upon 6? 5 volts upon 6. 5 volts upon 6 ohms plus 2 volts upon 5 ohms. That will give you your I2. So it will be 2 upon 5 plus 5 upon 6. That is equal to 1.23 amperes. This is the source current at node B. So the nodal equations will be 1.83 VA minus 0.33 VB is equals to 10 and minus 0.33 VA plus 0.7 VB is equals to 1.23. That's how you get the nodal equations. That's it for today's session. Thank you.